Hello students, welcome to the class of Circuit Theory and Network. This video has been prepared for CSC third semester students. I am Priyanjali Mukherjee, Assistant Professor of Electrical Engineering Department of Narula Institute of Technology. In this class, I will discuss on the interrelationship of two-port parameters. In this video, we'll discuss on the transformation and necessary steps of different parameter conversion and the Z and Y parameter in terms of the remaining parameter such as H or the ABCD parameter and two-port parameters conversion with example and cascaded two-port networks. So first start with the transformation and necessary steps of parameter conversion. Now the four parameters which we have learned in the previous videos, that is the Z, Y, ABCD and hybrid parameter, are generally used to describe the linear networks and these are interchangeable. So the conversion between them is often used and which is very much important in case of circuit design. Now all the parameters are the same for the two-port network, that means they are interrelated. Now one set of parameters may be expressed in terms of the other set. So let's check the necessary steps for the transformation. So first we need to write the standard equation for both the parameter sets. Next we need to solve the equations of the second set for the dependent variable of the first set of equations, and then we need to express the equations in form of the equations of the first set, and then we will compare the equations obtained in the second set and with those of the first set to obtain the required parameters. So let's take an example. First, we need to convert the Z parameter in terms of Y parameter. So we know the relation between Z and Y. Z is the impedance where Y is the admittance. And as the impedance is the ratio of V by I, whereas the admittance is the ratio of I by V, so we can say that the Z equal to Y inverse. Now for this two-port parameter, Z can be expressed as Z11, Z12, Z21 and Z22, and these equal to Y of inverse. Now we are converting the inverse function, that is Y11, Y12, Y21 and Y22 inverse, which becomes Y22 minus Y21 minus Y12, Y11 whole transpose by the determinant, that is equal to delta Y over here. So it becomes Y22 minus Y12 minus Y21 and Y11 by delta into Y. So delta Y is the Y11 into Y22 minus Y12 into Y21. So we can rewrite this equation matrix in this form, that Y22 by delta Y minus Y12 by delta Y, and this becomes minus Y21 by delta Y, and this Y11 by delta Y. So by comparing this Y matrix inverse Y with this Z11, Z12, Z21 and Z22, we can say that this term Z11 is equal to Y22 by delta Y, whereas this Z12 is ratio of minus of Y12 and delta Y. Z21 is the ratio of minus Y21 and delta Y, whereas Z22 is the ratio of Y11 and delta 1. So in this way, we can convert the express the Z parameter in terms of the Y parameter. Next is the Z parameters in terms of the hybrid parameter. So here these are the generalized equations for the different parameters. So first we need to express the Z parameter in terms of H parameter. So first we are considering the equation 3a and 3b, that is the general equation of hybrid parameter. And from this equation, second equation, I2 equal to H21 into I1 plus H22 into V2. So from this equation, we can find out that V2 equal to I2 by H22 minus H21 into I1 by H22. Now we can substitute this value to the equation V1 equal to H11 into I1 plus H12 into V2. So here V1 becomes H11 I1 plus H12 into this V2. So from this equation we can rewrite this, and it is finally delta H into I1 by H22 plus H12 into I2 by H22. Now we can compare this equation 5 and this equation 6 with the generalized equation of Z parameter. So it becomes that Z11 equal to delta H, that is the H11 into H12 minus of H21 into H22, that is the delta H by H22. And Z12 is H12 and by H22, Z21 is minus of H21 by H22, whereas Z22 equal to 1 by H22, because this equation is Z11 I1 plus Z12 into I2. So by comparing, we can find out all the Z parameters in terms of H parameters. Next, we are converting the Z parameter in terms of ABCD parameter or the transmission parameter. So here this is the equation of transmission parameter, and that is equal to V1 equal to AV2 minus BI2, and this equation is I1 equal to CV2 minus BI2. So from this equation 4b, we can write that I1 equal to CV2 minus BI2, or V2 becomes I1 by C plus BI2 by C. Now we can substitute this value of V2 into this equation, V1 equal to A into V2 minus B into I2. So it can be rewrite as V1 equal to A by C into I1 plus AD minus BC into I2. Now we can compare this equation 7 and equation 8 with the equation of Z parameters. So if we compare this equation 8 with the equation 1a, so we can find out Z11 and Z12, and that is the ratio of A by C, whereas Z12 is AD minus BC by C. And if we compare the equation 7, that is V2 equal to I1 by C plus DI2 by C with this 1b equation, then we can say that Z21 equal to 1 by C, whereas Z22 equal to B divided by C. So in this way, we are expressing the Z parameter in terms of the ABCD parameter. Next, we can take another example of Y parameter in terms of Z. And previously, we have seen that Y and Z are the inverse of each other. So Y can be written as Z inverse. So in the same manner, we can find out that the Y11 is ratio of Z22 and delta Z, whereas Y12 is the ratio of minus of Z12 and delta Z, and Y21 is the ratio of minus Z21 by delta Z, and Y22 is Z11 by delta Z. And here also the delta Z is Z11 into Z22 minus Z12 into Z21. this portion is known as the delta Z. So in the same manner, we can express the Y parameter in terms of the Z parameter. And next, check how we can express the Y parameter in terms of hybrid parameter. So the method is same. Here we are considering the H parameter equations, and from the equation V1 equal to H11 into I1 plus H1 to V2, we can use that I1 is equal to V1 by H11 minus H12 into V2 by H11, and we can substitute this value of I1 into the second equation. So we can rewrite the equation like this: I2 equal to H21 into, this is the I1 plus H22 into V2. So we can rewrite this equation like this, that is I2 is equal to H21 by H11 into V1 plus delta H by H11 into V2. So by comparing these two equations with the Y parameter equations, that is 2a and 2b, we can find out the different parameters Y11, Y12, Y21 and Y22 in terms of the H parameters. And again we are converting the Y into ABCD parameter. So ABCD parameter equations is given as P1 equal to AB2 minus BI2 and I1 equal to CB2 minus BI2. So from the first equation for A, we can find out the value of I2, that becomes AB2 by B minus B1 by B. And we can substitute this equation into the second equation, that is I1 equal to CB2 minus BI2. So from these two equations, we can compare these with the equation of Y parameter, that is 2 and 2b, and we can express Y11 in the terms of ABCD, that is B by B, whereas Y12 equal to minus of AB minus BC by B, Y21 equal to minus 1 by B, and Y22 is equal to A by B. So let's check, these are the all four parameters, and here we can convert one parameter from another parameter, that means from Z to Y. We'll use this formula, that is Z11 equal to Y22 by delta Y, Z12 equal to minus of Y12 by delta Y, whereas Z21 equal to minus Y21 by delta Y, and Z22 equal to Y11 by delta Y. And in using this formula, we can find out any conversion of one parameter to another parameter. So let's take an example. Here, normal T form is given, and we have to find out the H parameter of the given network. So this configuration can be represented by Z. And if we consider that this is ZA, this 1 ohm is ZB, and this 1 ohm is ZC, so and the voltages are remaining same, that is the input voltage is V1 and output voltage is V2. So we can rewrite these equations: V1, that is the input voltage. When V1 is applied here, then we can say that this I1 current is flowing through this one. So we can write down the KVL equation: V1 equal to I1 into this ZA plus ZC, and in that case through ZC both the I1 and both the I2 current is flowing. So ZC into I1 plus I2, and it can be rewrite as I1 into ZA plus ZC plus ZC into I2. Similarly, for the V2, we can say that I2 is flowing through this 1 ohm, whereas through this 2 ohm, both I1 and I2 is flowing. So when we are applying the KVL in this loop, then we can write V2 is equal to I2 into this is ZB plus this is ZC into this I1 plus I2. So it can be written as ZC into I1 plus I2 into ZB plus ZC. Now we can compare with the Z parameter governing equation. So we can write that Z becomes the ZA plus ZC. This is ZC, and this Z22 becomes ZB plus ZC. Just by comparing these two equations with the governing equation of Z parameter. So now ZA plus ZC. So ZA plus ZC becomes 3 ohm, whereas ZC is 2 ohm, and ZB plus ZC is also 3 ohm. So Z parameters becomes 3223. Next, we need to find out the H parameters. And from the previous table, we can say that H11 is the delta Z by Z22. Now, delta Z is the determinant of this Z. So, its determinant becomes 3 into 3, that is 9, minus 2 into 2, 4, that becomes 5, divided by Z22. And Z22 is ZB plus ZC, that is equal to 3. So, H11 is 5 by 3. For H12, the formula becomes Z12 by Z22. Now Z12 is this 2 divided by Z22 is 3. So H12 becomes 2 by 3. Whereas H21 is ratio of minus Z21 by Z22. Now Z21 is 2 and Z22 is 3. So H21 becomes minus 2 by 3. Whereas the H22 is 1 by Z22. That means simply 1 by 3. So the overall H parameter can be written as like this: 5 by 3, 2 by 3, minus 2 by 3 and 1 by 3. So without calculating in H, we can converting from Z to H, and we can easily find out the H parameter by using the conversion method. Next is the connection of two-port networks. Now there are different configurations are there. So first is the cascaded connection, and this cascaded connection are useful for the ABCD network, and whereas the parallel is used for the Y parameters are useful. So let's take an example of cascaded connection. Now cascaded connection means the output of the first network is used as the input of the second network. So here there are two networks. First one is network A and second one is network B, and output of the first network is used as the input of the second network. And here we can see that V2A, that is the output of the first network, that is equal to V1 into B. That is the input of the first network, and the direction of currents are opposite. I2A is equal to minus I1 into B. Now here the transmission parameters are useful in this connection. So for this network, we can write the equation like this: V1 I1, that is equal to actually this A11 becomes A, B, C, D. So if we know the ABCD parameters, we can change this A11, A12, A21, A22 by ABCD. So here I am using the general formula A11, A12, A21 and A22 and V2 into minus I2A, because this is the form of the ABCD parameters. And for the second one, it can be written as V1B VIB equal to A11, A12, A21, A22 of B and into V2 minus of I2. So V of 2A, that is equal to V of 1B, because output of this equal to the input of the second network, and the current are opposite. So V of 2A and minus of I2A, that is equal to V1B and I1B, and this V1 I1 is equal to this parameter, this is ABCD parameter of A network into the ABCD parameter of B network into V2 minus of I2. That means when these two connections are two networks are connected in the cascade connection, then if it is the ABCD network, then the ABCD parameters are multiplied. So in this way, we can add two different networks in a single connection. So these are the references. Thank you.
Hope after this video lecture you have a clear idea about today's topic. Now we will go through some questions answer session in the context of this video lecture. Now you are requested to go through gradually and try to solve the MCQ questions by your own. Answers are also attached at the end of each question.